How did life first appear on Earth? How did life first appear on Earth? So, look, the universe is 13.8 billion years old, roughly. Our solar system is 4.6 roughly billion years old. The Earth is about 4.5 billion years old. And life appears on Earth about 3.8 billion years before today, roughly, approximately, plus or minus whatever. So life appears on Earth, and then life proliferates on Earth, and then we end up with us, very complicated, complex human beings. Now, what is the common thing in life? What do all life forms on our planet, whether they're viruses or bacteria or birds or octopuses or humans or chimpanzees or gorillas or donkeys or whatever, fishes, what do all of them have in common? They have something in common, all of them, despite being so different. DNA, the genetic code, the genome, the blueprint for life. So the genome is the blueprint of how to create proteins, how proteins are created. Proteins are these incredibly complex molecules that are the basis and the fundamental of life. Your muscles, everything is made of proteins. So the DNA genome is the blueprint of how to code those proteins, and without proteins you can't have DNA. It's kind of interconnected. Now, the genome of human beings is quite complicated. It's about twice as large as the genome of fish. The genome of fish is twice as large as the genome of a worm, let's say. The genome of a worm is about, I don't know. So, so it is believed that it is observed that the size of the genome doubles roughly every 300 or 500 million years, maybe 300 million years. So if we go back in time and we want to arrive at the simplest possible genome, you would have to go back roughly 10 billion years to arrive at the very fundamental, simplest genome with just a few base pairs. But our planet is only 4.5 billion years old, and life originated only 3.8 billion years ago. But to arrive at the most fundamental kind of genome, you have to go back about 10 billion years. How does that work? Makes no sense. So it looks like life appeared on Earth rather well advanced and well formed, with a rather complex genome in the most fundamentalist organisms, which is weird. It is very weird. So how could one explain that? That the first genome that appeared on Earth was already well made and pretty complex. It did not have the time to evolve into that much of a complex thing. So how did it evolve? Obviously, evolution must have happened. So the answer is maybe maybe life evolved outside our planet. What were conditions like 10 billion years before today? The universe was very different. It was much smaller, much hotter than it is today. Right now, the average temperature of interstellar space is about 2.7 degrees Kelvin. Sorry, 2.7 Kelvin. What on earth am I saying? Not degrees Kelvin. 2.7 Kelvin. Roughly. That's the temperature of the average cosmic wave CMBR photon, cosmic microwave background radiation photon. But in the past, it was much warmer. So there was a time after the Big Bang when the temperature of interstellar space was precisely in the Goldilocks zone, between 4 to 100 degrees Celsius, the temperature range in which water is liquid. There was a time period, okay, when the universe's average temperature was that, which means that liquid water just naturally would have occurred in space. And maybe it's then that the first life, the first DNA molecules somehow evolved over millions, tens of millions, hundreds of millions, billions of years. And because life could just appear in space, in interstellar space, so that's why this genetic material was seeded everywhere in the universe, because the universe was much smaller then, on asteroids, on space dust, on God knows what else. And maybe these seeds of life have been drifting all across the cosmos for billions of years. And maybe after our planet was formed, maybe there was an impact of an asteroid which carried this blueprint of life, already reasonably well developed. And that's how life was seeded on Earth. Maybe that is how it happened. Do we have evidence of this? Absolutely none. Does it make sense scientifically? Yes, it does. It's a plausible theory of which we have no evidence thus far. Maybe we will never have evidence of this far. But the question is there, that how did a highly advanced genome appear on Earth? When we know that the genome size doubles once in every 300 or so million years. So if we go back 3.8 billion years, we come up with a very large genome, not a very rudimentary fundamental genome. So to arrive at that, you have to go back about 10 billion years, which makes no sense unless life actually originated outside our planet, in the deep antiquity of our universe, even before the sun itself was born.